Every single time you turn on your kitchen faucet, the pouring water may look absolutely crystal clear. However, beneath that sparkling surface, a hidden army of invisible contaminants could be quietly lurking inside your glass. We are talking about microscopic bacteria, toxic industrial chemicals, heavy metals, and millions of tiny microplastics. Clean drinking water is far rarer than most people think, which is why the humble water filter has become one of the most vital life-saving inventions in human history. But have you ever wondered what actually happens deep inside that filtration cartridge? How can a small device instantly transform contaminated water into something perfectly safe to drink? If you want to uncover the fascinating chemistry and engineering secrets that keep you alive, then you must keep watching. Before we dive into this liquid mystery, please hit that subscribe button right now and turn on notifications. Welcome to Deep Xplain. Let us discover the jaw-dropping evolution of water filtration. To truly comprehend how a modern water filter achieves its daily miracles, we must travel back thousands of years into human history. Ancient civilizations, including the early Egyptians, the Greeks, and the wise healers of ancient India, already deeply understood that cleaner-looking water led to much better health. Around 2,000 years before the Common Era, people were already using simple beds of sand and coarse gravel to physically strain thick dirt from their muddy water supplies. Later, the famous Greek physician, Hippocrates, designed one of the earliest official filtration devices in human history, which became known as the Hippocratic sleeve. This simple device was a cloth bag designed to strain out heavy sediments from boiled water, ensuring a cleaner liquid for his medical patients. However, as human populations exploded and cities grew rapidly during the Industrial Revolution, water contamination quickly transformed into a deadly, terrifying crisis. Dark, polluted rivers began spreading horrific diseases like cholera and typhoid, killing thousands of citizens every single day. This catastrophic health crisis brutally forced scientists and innovative engineers to rapidly develop the very first modern filtration systems. During the 19th century, massive sand filtration plants were successfully introduced in major metropolitan cities. And eventually, the brilliant discovery of activated carbon filters alongside advanced chemical treatments completely revolutionized global water purification. Today, these advanced technologies have shrunk down to fit everywhere, from household kitchen pitchers and refrigerator doors to massive municipal treatment facilities, and even high-tech life support systems aboard interstellar spacecraft. Despite all of these incredible modern upgrades, the core fundamental philosophy remains exactly the same as it was 4,000 years ago to forcefully separate harmful substances from clean, life-giving water. At its simplest mechanical level, a modern water filter acts like an absolute physical barrier that traps or chemically removes unwanted particles while allowing pure water molecules to pass through completely unhindered. Different filters utilize vastly different methods depending on the specific type of deadly contaminants they are engineered to destroy. One of the most foundational and common methods utilized today is mechanical filtration. In this physical process, water is forced through microscopic pores or fine mesh screens that physically block floating dirt, red rust, fine sand, and macro debris. Imagine pouring a large pot of pasta through a kitchen strainer. The visible holes allow the liquid to pass, but completely stop the larger pieces. Mechanical water filters operate on this exact simple principle, except the physical holes are completely microscopic. These holes are engineered to be small enough to capture floating particles that are entirely invisible to the human eye. In fact, some high-performance, modern mechanical filters are so advanced they can successfully trap microscopic bacteria and dangerous waterborne parasites, preventing them from ever reaching your lips. Beyond simple physical straining, another massive filtration method relies heavily on activated carbon, which is found inside almost every household water pitcher. Activated carbon is a specially treated form of natural charcoal that has been blasted to create millions of microscopic pores. This unique treatment dramatically increases its total surface area to an absolutely mind-blowing degree. Instead of simply blocking traveling contaminants like a net, The activated carbon chemically attracts and absorbs them through a unique scientific process called adsorption. Dangerous chemical compounds like industrial chlorine, agricultural pesticides, foul odors, and unpleasant tastes instantly stick to the massive carbon surface as the water flows past. This specific absorption is the exact reason why filtered water tastes significantly fresher, crisper, and cleaner than standard tap water. While activated carbon is incredibly effective at removing bad smells and chemicals, it usually works best when combined with other advanced systems because it cannot remove every single type of heavy contaminant on its own. For the absolute highest level of purity, the most advanced household systems utilize a process called reverse osmosis, which is frequently abbreviated as reverse osmosis filtration. This incredible technology forcefully pumps water through an extremely fine, semi-permeable membrane under intense mechanical pressure. The physical structure of this membrane is so selective that it only allows individual water molecules to squeeze through while completely blocking dissolved mineral salts, heavy metals, toxic bacteria, and thousands of harmful chemical residues. Reverse osmosis systems are powerful enough to remove devastating contaminants like heavy lead, toxic arsenic, and concentrated fluoride, making them wildly popular in modern homes and global industries alike. In fact, reverse osmosis technology is so incredibly powerful, it is widely used to desalinate harsh seawater, converting it into fresh drinking water for entire nations facing extreme freshwater shortages. However, reverse osmosis systems are notoriously slow and they naturally waste a significant amount of water during the purification process. This is exactly why many home systems combine reverse osmosis with carbon and sediment filters to achieve the absolute highest level of efficiency. In addition to these methods, modern engineering utilizes ultraviolet filtration systems, which focus entirely on killing live microorganisms rather than removing physical particles. These systems expose the rushing water to intense ultraviolet light, which instantly damages the core deoxyribonucleic acid of bacteria, viruses, and deadly pathogens, making it completely impossible for them to reproduce. Ultraviolet filtration is highly effective because it disinfects the water completely without adding any artificial chemicals. However, ultraviolet systems must be paired with traditional sediment filters because light alone cannot remove dirt or chemical pollution. Modern water filtration has become more important than ever before because global pollution is increasing rapidly worldwide. Tiny, indestructible plastic particles called microplastics have been discovered in major rivers, deep oceans, bottled water, and even falling rainwater. Industrial chemicals and pharmaceutical residues are also becoming terrifyingly common in municipal water supplies. As a direct result, water filters continue to evolve, utilizing advanced nanotechnology to build smarter materials and more compact multi-stage systems that fit easily inside a standard kitchen. At the end of the day, these devices are life-saving tools, protecting human health every single hour. It is truly mind-blowing how the human body is made of around 60% water, making this simple liquid the very foundation of life itself. Understanding how these filters work reminds us that clean water is not a luxury, but an absolute necessity for survival. If you want us to explore another hidden mystery, or if there is a specific engineering marvel you want explained next, please comment your detailed video suggestions down below so I can read them. Your detailed comments are our ultimate motivation to create more high-quality videos. Thank you for watching Xplain. Stay healthy, and we will see you in our very next episode.